This video is about the identification and classification of triangles, which form part of the geometry of two-dimensional shapes. Now, we can classify triangles based on either their side properties or on their angle properties, or best, in fact, a combination of these two. So, when we look in terms of sides, we know a triangle has three sides. If all three of these sides are unequal, we have what we refer to as a scalene triangle. Now, there's also a very specific relationship between angles and side lengths in triangles. So, if in fact all the sides are different lengths, it means all the various angles will also have different sizes. So a scalene triangle not only have no equal sides, it also have no equal angles. Our other possibility is that two sides are equal. So remember this line here and this corresponding line there means that these sides are equal. It's the symbol for being that they are equal. So we also see that we have two angles that are equal, because if two sides are equal, two angles will have to be equal. So when we have two sides equal or two angles equal, then we refer to it as isosceles triangles. Our other scenario is where in fact all three the sides are equal, which also means in fact all three the angles are equal because of our direct relationship between the lengths of a triangle and the angle sizes. We refer to this as an equilateral triangle. So for equilateral triangle, we have three equal sides and three equal angles. And because we know a triangle has 180 degrees, if we add up all the interior or inside angles, 180 divided by 3 will give you indeed 60 degrees. So that is why equilateral triangle always have three angles of 60 degrees and three sides equal. So there's a very specific relationship between, as mentioned before, the sides of a triangle and the angle lengths. For example, in this triangle, 87 degrees is the largest angle. If you go opposite it, you will find that that side opposite the largest angle will also be the longest side. So the largest angle will result in opposite it the longest side. Similarly, the smallest angle, in this case it's 37 degrees, so the smallest angle, if you go opposite it, you will get the shortest side. So the 56 that's in the middle, that will be the length that's not the longest, neither the shortest of the triangle. So now let's look at the classification of triangles based on their sides and angles. Now if you think of classification, you can basically think of grouping things together based on their characteristics. For example, if we look at Eric Louw's school, we know we have for the grade 8 and 9s the abbreviations ER, IC, where the E refers to all the learners that are, for example, together based due to their language of Afrikaans. So we classify all the Afrikaans learners that are in grade 8, for example, as grade 8E learners. We know for the seniors we have LOUW, for example. So for the seniors it's actually even better to illustrate, because we have for the L all the Afrikaans learners grouped together, and then we have for the W we have all the Tshivenda learners together. So we can classify, for example, all the grade 10 Tshivenda learners as 10W. They fit into class 10W. And all the Afrikaans grade 10 learners fit into grade 10L. And then, very particular with the grade 10s, all the learners that take maths, that are taking English also as first language or home language, are the 10O class. And all the math lit learners in grade 10 that has English home language are grouped together in the 10U class. So this is just a practical example of classification, so that you understand what classify means. It's basically grouped together according to certain characteristics that the group has in common. So now we already know that in terms of sides, we have the scalene, where all three sides are unequal. We have the isosceles, where two of the three sides are equal, and then we have the equilateral, where all the sides are equal. So if we go to the properties, we can in fact see no equal sides, two equal sides, three equal sides. When we look at the angles, because there are no equal sides, there are also no equal angles for scalene triangles. For isosceles triangles, because we have two equal sides, we will have two equal angles. That's a property of the isosceles triangle. And when it comes to the equilateral triangle, because we have three sides equal, we also will have three angles of each one being 60 degrees. Because the sum of the angles of a triangle is 180, and 60 times 3 will give you 180 degrees. Now, we use the basic classification according to side, and then combine with that the angle properties. So we have the side properties, we combine them with the angle properties. So the first row is all about scalene, where you can see none of the sides are equal. We have a side 1, a side length 2, a side length 3. Three different sides for all three scenarios. So now that we know we are dealing with scalene triangles, let's look at the angles. You can see in the first case all the angles are smaller than 90 degrees. So we can think of a small child which is cute. So we refer to these as acute angled triangles. So this is an acute angled scalene triangle. The next scenario for scalene triangle, where all the sides are unequal, is that in fact we have one 90-degree angle. So this is the symbol for the 90-degree angle. So we call a 90-degree angle a right angle. So this will be an example of a right angled scalene triangle. And then finally, we have the scenario where we have an angle of greater than 90 degrees, in this case 93 degrees. angles are still unequal since it's a scalene triangle. So we refer to even angle is larger than 90 degrees. It's an obtuse angled triangle. Similarly, we can look at the isosceles case where we know two angles are equal and two sides are equal. Now, we see we have one side and another side equal, so these two blue sides are equal. We can also see opposite the blue side we have a 52-degree angle, opposite the other blue side we have a 52-degree angle, because we know there's a direct relationship between side lengths and angle sizes. And then we see the third remaining one is 76 degrees, so none of these angles are bigger than 90 degrees. They're all smaller than 90 degrees. So again, it's our acute angled isosceles triangle this. In the next scenario, we again have a 90-degree angle with two sides equal, so therefore we will also have the two corresponding angles equal. So in this case, because we have a 90-degree angle, we refer to it as a right-angled isosceles triangle. And then we also have the scenario where we have two sides equal, therefore two angles equal, but the other side is in fact bigger than 90 degrees. So it is our obtuse angled isosceles triangle. And then finally, we know we have our equilateral triangles where in terms of sides, all three sides are equal. So we have 1, 2, 3 sides equal, and in this case all of them will always be 60 degrees. So they are all acute angled. So we actually just can refer to an equilateral triangle because we know it will be a acute angled triangle. We can't have a right angled equilateral triangle, neither an obtuse angled equilateral triangle. So let's look at a few examples of how to classify these triangles formally. So exercise 11.1, number 1, I'm going to work through a few examples. So number 1, let's look at number B. We have to classify each of these triangles and give reasons for your answers. So reasons in 2D or two-dimensional geometry is very important. So now I don't see any information given about the side lengths. We don't know anything about that explicitly. But what we do see is we have 1, 2, 3 different size angles. So all these angles are different sizes. So none of them match. So if all the angles are unequal, it must be a scalene triangle. So we can say that it's a scalene triangle. Furthermore, we also know that all the angles are smaller than 90 degrees. So we think about a small child, an acute child. So let's refer to it as an acute angled scalene triangle. So we can say triangle DEF is an acute angled scalene triangle. So now we made our statement. What was our reasons? Well, we know angle E is unequal to angle D is unequal to angle F, and all angles smaller than 90 degrees. Okay, so since all the angles are unequal, we know it's a scalene. And since all angles are smaller than 90 degrees, we know it's an acute angled one. So we have an acute angled scalene triangle. So let's look at another one, number 1C. So we have a 90-degree angle. So we know it must be a right angled triangle. We have 145-degree size angle. We know what I is. We can calculate it. So that will be the first step. We can say angle I is equal to 90 degrees plus 45 degrees. And that we have to subtract from 180 degrees. So we have 180 degrees minus 90 plus 45 degrees. Our reason, very important, is angle sum of triangle. Okay, so you can abbreviate it. You don't have to write out angle sum of a triangle. You can use the triangle symbol. You can use the nearly L, sideways L kind of as the angle symbol. So therefore, we know that angle A is 180 degrees minus 90 plus 45 is 135 degrees. So therefore angle I equals 45 degrees. So since we have two angles that are equal, we know it has to be an isosceles triangle as well. So we know it's a right angle because of 90-degree angle, and then isosceles because of two angles that has the same size. So we can say triangle GHI, this is our statement. So triangle GHI is an is a rather right angled, because it's 90 degrees, a right angled isosceles triangle. Reasons being angle H equals 90 degree, that's the right angled portion, and then also we know angle G is equal to angle I. That is the isosceles portion reasoning. Finally, let's look at number H. So for number H, I can see we have this, and this side is marked as equal. So therefore, opposite this side, we have to look at this angle. So this angle, we will have to compare to the angle opposite this side. So therefore, these two angles are equal. So therefore, angle V must also be 80 degrees. So we have two angles of 80 degrees. So meaning therefore that the third angle will be 180 degrees minus 2 times 80 degrees, because we have two angles of 80 degrees, which is 160 degrees. So therefore we have 20 degrees. So this angle is 20 degrees. So all these angles are less than 90 degrees, so therefore it must be in an acute angled triangle, and because we have two sides and two angles that is equal, it also has to be an isosceles triangle. So therefore we can say triangle UVW is an acute angled isosceles triangle. That's our statement. So let's get our reasoning. Okay, we know that we have two sides that are equal. That will explain the isosceles part. And so we can say UW, that side is equal to VW. And then in terms of acute, we know that all angles smaller than 90 degrees